In this episode, absolute value inequalities coming up back into action. Hey guys, today I will show you how to solve absolute value inequalities. Say we're given something like this: absolute value bars or modulus of 8x plus 4 greater than or equal to 12. Well, the idea is the absolute value bars can be dropped off by taking whatever you have inside of your absolute value bars with positive or negative sign. Well, I will show you what I mean by this. So all you need to do is just simply split up your inequality into two. The first one comes whatever you have inside. So in this case, it's 8x plus 4. So we take it whatever it is without any changing. So basically it's a positive version of whatever you have, whatever your expression is underneath your absolute value bars. And you set it so basically the same. You keep the same sign and whatever you have on your right side. Now, the second inequality comes from here, but we're going to take the negative version of whatever you have inside. So inside you have 8x plus 4. So I'm going to write this negative sign in front. So this is your negative version. And you always keep whatever you have left over. So you don't want to change anything. So it's greater than or equal to 12. So that means we got rid of, we eliminate, we drop off, we left behind these absolute value bars. And now it comes down to solving just normal linear inequalities in one variable. And by the way, if you need help with solving these linear inequalities, I have a separate playlist on inequalities and you could check it out later. Now, let's solve them separately down below. So for the first one, typically you want to move all your constant on the right side, and typically you want to leave your x on the left side. So let's move 4 to the right side by subtracting 4 from both sides of your inequalities. So minus 4 minus 4. And then in the next line, it becomes 8x greater than or equal. So you keep sign, you don't want to change it. So since 12 minus 4 leaves you just 8. And the next step, you want to divide both sides of your inequality by whatever is in front of your x. So 8 is attached to your x, so you want to divide through both sides. So 8 goes away, disappears, drops out, and your x is greater than or equal to 1, since 8 goes into 8 once. Alright, so this is part of your solution, but at this point we are not done yet. So we have to solve the second inequality. So steps are pretty the same. So first of all, we have to distribute this negative. So all sign would be flipped, would be switched. So it becomes negative 8x minus 4 greater than or equal to 12. And again, we're going to move this 4 to the right side by adding 4 to both sides. So just add 4 to both sides. So we have to do to both sides so we don't change the overall value of your inequality. Drop down negative x negative 8x at this point. So 4 goes away, disappeared, and on the right side you would be left with 16. And finally, the last step. So whatever you have in front of your x, you want to get rid of this. Eliminate by dividing through this number. So in this case it's negative 8. So I'm going to divide both sides by negative 8. Now this 8 drops out, goes away, and you would be left with just x. And now be careful, caution. Since we are dividing by a negative number both sides of your inequality, the sign in the middle has to be flipped, has to be changed. So the direction of your inequality has to be switched to the opposite. So be careful over here. I will put just kind of exclamation mark because of this negative, because of dividing by the negative number. The same thing goes for multiplying by a negative. So it becomes less than or equal. So not greater than or equal, but less than or equal to. And this fraction needs to be simplified a little bit. So overall it's negative, comes from this negative. So 8 goes into 16 twice, and you would be left with negative 2. So this is your second solution set. So basically again, for your answer, for your final solution sets, since this is absolute value inequality and your solution is a infinitely many x's, it's a set. It's a set in math. So basically it's all x's that satisfy both of these two inequalities. So your x's are greater than or equal to 1, and also less than or equal to negative 2. Let me show quickly the last one. So this is a little bit different from what we did before, since you are given an expression on the right side. Before it was just a single number. However, the steps are the same. All you do is just split it up, break it up into two separate inequalities. So the first one comes just by taking whatever you have inside of your absolute value bars. So in this case it's 2x minus 4. So basically we are taking this with a positive sign. It's a positive version whatever you have inside, and you keep your sign and the right side as is. So no absolute value bars. We got rid of this. The second one, we're going to take the negative version, what basically your absolute value function spits out. So negative version of inside. So negative. And because I have the expression, so I have to draw the parentheses. So it's a good policy to draw the parentheses. And 2x minus 4 goes inside of your parentheses, greater than x plus 3. So two separate linear inequalities, and now you have to solve them separately, normally, like you usually would do. So let me just quickly go through this. So we want to move this x to the left side by taking off this x from both sides. So minus x, subtract x from both sides. And also we want to move this negative 4 to the right side by adding 4 to both sides. So let's do it simultaneously. So add 4 plus 4 to both sides. So the next line, So 2x minus x gives you just single x. You keep the sign, just drop it down. This x's goes away, disappeared, no x's, and 3 plus 4 gives you positive 7. So this is part of your solution. So the same steps, we're going to solve the second one. So first thing to do, first of all, distribute this negative and signs in front of your terms flipped, switched. So negative 2x plus 4, so the sign of flip, greater than x plus 3. And again, we want to solve it for x, so we're going to collect x's on one side, so I'm going to move this x to the left side by subtracting x from both sides of your inequalities. And at the same time, simultaneously, I'm going to move this 4 to the right side by taking away 4. So minus 4 from both sides. So negative 2x minus x becomes negative 3x. You keep the sign, drop it down, carry it down. So this 4 goes away, disappeared, drops out. And on the right side, you will be left with this x's goes away. 3 minus 4 gives you negative 1. And finally, the last step. So we want to divide both sides of your inequality by this negative 3, the number that attached x. So you divide by negative 3, both sides. And you are left with, again, be careful, since we are dividing through by a negative number, so the sign has to be flipped. So instead of greater, I'm going to write less than, and this fraction becomes positive overall, and it's just a third, so x less than a third. Again, this is your second part of your solution. So this is this part, and this component, this is your entire solution for this absolute value inequality. Well, I hope it helps you. Well, train your brain, and thanks for watching. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new release.